6, lesson 7. So what this section's about is the ambiguous case of sine law. There's a type of triangle where there could be a possible two answers. Okay, and we're going to talk about that right here. Okay, so you have two students here who have the same side and angle measurements, but they have different triangles that are not congruent. Scott has a 30-degree angle that makes a 4. Okay, and then a 6 next to it. Brittany has a 30-degree that makes a 4 and a 6 next to it. But as you can see, angle C is completely different. Okay, it's completely different. And this is where the ambiguous case comes into play. Now, this lesson kind of has a lot that says use a protractor and stuff like that. I'm just going to kind of go through it, kind of roughly doing it. You're welcome to. I have protractor stuff if you'd like. You're welcome to do that on your own if you want. Some of it is kind of neat. But anyway, so the first thing it says, just confirm that their degrees are correct. They are correct, so this one's just a yes. Okay, they are correct. Okay, and then part B, it says estimate what angle C is for each of them. So just by estimating, like this one here, I'd say probably a little bigger than half. So my estimation for Scott's angle C would be 50 degrees for Scott. Okay, then for Brittany, hers is an obtuse angle, so I'd probably say 125, 130. Okay, it's an estimation. Okay, so those are the two estimations. And now we're going to set up the sine law with both of them. Now you'll see the problem here is when I set up the sine law, you have the same setup, the same exact one. So when I do this down here for C, we'll do Scott first. So Scott, his would be sine C over C equals sine B over B. Okay, we have everything but the angle C. So it's going to be sine C over 6 equals sine 30 over 4. And then what we do here is we just times 6 to both sides. So we're going to get that sine C equals 6 times sine 30 over 4. And then that would be, when you put this chunk here into your calculator, it's going to give you 0.75. So sine inverse of 0.75 will equal C. So for C, we get 49, which is close. Scott, we said 50. Okay. So C is 49. Okay, so then to do for Brittany's, we'll have the same setup. So I don't need to do Brittany's all totally different. For hers, the only thing different is that we understand that if it's obtuse, what quadrant is Brittany's angle going to be in? So 1 is 0 to 90, so 2, because hers is bigger than 90. So she's going to be in quadrant 2. And we're going to use 49 as a reference angle. So 49, so then her angle, okay, would be 131. So same work. We just know hers is obtuse. So we go 180 minus the 49. We get 131 for Brittany's. And on hers, we guess 130. So this is the actual ambiguous case here. That was a picture above of two triangles that have the same measurements but create a different angle. Okay, and we'll talk about now kind of how that's created. Any questions? Okay. All right. So, kind of talking about constructing congruent triangles. Okay, and back to my experience teaching advanced geometry in my previous teaching jobs. Okay, we can consider these congruent statements. Okay, and what this is we're trying to figure out which are congruent statements, which means this. If you have all three sides of two triangles equal, are they congruent? Yes. Because if I draw this here, they're P, Q, and R. PQ is 3, PR is 4, and QR is 6. What this does is I have three different sides locked in. What I mean by that is I have this side, and this side locked in. Angles created those. Okay? So if I draw a triangle anywhere else and it has 3, 6, 4 for the sides, it's going to be congruent. Okay? So this one, the question says, can you draw a triangle with these measurements that's not congruent? No, you can't. You can't because side, side, side is a congruent statement. Okay? So again, what that asking is asking you, if they give you 3, 6, 4, if you draw another 3, 6, 4 triangle, will it be congruent? Yes. Same. Good. Yeah, congruent means the same. Okay? Side, angle, side. Okay, so if I'm doing side, angle, side here, let's just draw another P, Q, R. PQ is 5, QR is 4, angle PQR is 40. Okay, what I like to think about, like I told you last one, I like to think about how many sides does it have locked in. The first one had 3 sides locked in because it gave us 3 sides. This one gives us 2 sides, but an angle that makes a third side. So now, again, we have 3 things locked in. And what I mean by 3 things is I mean that 3 things that are not related. 40 is not related to the 4 or the 5, right? So that makes us have, again, that's a congruent statement. This one also is a congruent statement. So this one, again, would be no. I can't make a triangle that is not congruent with those same measurements. Okay, no questions? All right, so let's get to the last 2 here, angle, side angle, and side, side angle. If you're playing the acronym game. So angle, side angle, we have, let's do this here, let's go P, Q, R. PQ is 3, PQR is 40, and QPR is 30. So if I look here, I have this side locked down, this angle makes this side, this angle makes this side. I have all 3. I have a piece of information of all 3 of my relationships. So again, this one is a congruent statement. So yes, it's a congruent statement. So no, I can't make a triangle with those measurements that is not going to be congruent. Okay? And then this one here is what we're getting to today. Okay, so side, side angle. So let's do that here. So it's going to be okay, so I'm going to label that P, R, and Q, like I have in my notes here. PR is 4. Okay, and PQR is 40, and PR is, where did PR? PQ is 6. Okay, so now if I look, back to what I've been telling you, this side goes this angle, so that's one side locked down. This side locked down, but the one we don't have anything about, P, we have nothing with those. So we only have 2 of 3, so this is not a congruent statement. Okay, this would be yes, I can. Okay, this is why I could take this point here, I can make an isosceles triangle with this side, okay, that also is 4, that still connects to Q. That's the ambiguous case. If you think about that last one, it was a triangle that was smaller to bigger. So if you look at this, and again, my drawing is probably a little bit off, okay, but see this angle is acute, this angle is obtuse. So it's got the acute and the obtuse option. Okay, that's for the side-side angle. We're going to get into some rules and stuff, but that comes from side-side angle. Okay, all right. All right, so this investigation here is supposed to have compasses, but I'll kind of show you the point. All right, so case one. This case one's where you have two possible answers or two possible triangles. Like what we just did there, there's two possible triangles. This is why. If I take from the center of A here, let me change the color. I set my compass to 3.5 centimeters. If I do that, it's going to give me something like this. What that means is, what's a compass do? When you have a compass and you're measuring a compass, it means everything's 3.5 from the middle, right? So what that means is, this and this, and my drawing could be a little bit off, are both 3.5. So that gives you two options. That's the point of today. Ambiguous case, two options. Okay, you kind of see those are pretty good. Those look pretty similar. Okay, so that's what the point is. So how many possible solutions are there? There's two. All right. So then that's all we're writing for this part, and then we'll do the second one. One unique triangle. You can kind of assume what that's probably going to be. If I set my compass, this is right from your book. If you set your compass at 3 centimeters, it would go and it hit once. Okay, it would hit once. So that means you'd have one solution. Okay, and the last one, no possible triangles. If you set yours to 2 centimeters, it wouldn't touch at all. So there'd be no intersection points, there'd be no answers. No solution is a possible answer today. Okay. All right, so kind of investigating. Now we're going to kind of go through a case-by-case setup. The whole beginning of this lesson is kind of a lot of definition and figuring things out, so just be patient. So in the previous investigation, we discovered that in the case of side-side-side, side-angle-side, and angle-side-angle, only one solution was possible. So what that means is when you have side-side-side, side-angle-side, or angle-side-angle, there's only one possible answer. But when you have SSA, you have 0, highlight. You have 0, 1, or 2 solutions possible. That's what we just did in the last page. You can have 2 intersections, 1 intersection, or no intersections. Okay? So what we're going to do here is we're going to go through these steps here, and we're going to kind of solve it more algebraically now. So case 1. AC is 2.5. Okay? AC is 2.5. And so that's going to give me, if I go to here, it's 2.5. And then my picture's not quite as accurate, but this right here is also 2.5. So this is a case of 2 possible. So we're going to use our sine law as step 2. This is C, sorry. C1 and that's C2 because there's 2 options. Okay, so sine of C, we don't know sine of C, but we know little c. Little c is 2.5. Oh, excuse me. C makes 3. This angle makes this side. This angle makes this side. They make 3, sorry. So sine C over 3, and then sine of 30 over 2.5. Okay, we do that work. It's going to come up to being sine C of 0.6. We want to go sine inverse of 0.6. That gives us a reference angle of 37. Since we're understanding there's 2 possible answers, an obtuse and an acute, 37 is one answer. Then we have to do 180 minus 37 to get our other answer, okay, which is going to give me 143. So those are my 2 answers, 37 and 143. Then now it says determine the measure of BAC. Well, BAC would be here or this big one. So there's 2 answers for that. So I have to go (180) minus the 30 minus the 143. So what I did was if it's 30 here and 143 here, how much do I have left? I only have 7 degrees left. And then I can also go 180 minus 30 minus the 37. So that's if it's a smaller angle. Just figure out the degrees in the triangle. In that case, it would be 113. Which you can see, these change from obtuse and acute as well. So say the solution of the problem, angle BAC is 7 degrees or 113. All right, case 2. Okay. So step 1. Okay, sketch a rough diagram below. So AC is 4 this time. That leaves me with only one option. Okay, because I can't go 4 and go past. So I'm going to stop. I'm going to go 4 where I can for it to connect. So that's where C would be. So AC being 4. Same setup. Sine C over 3 equals sine 30 over 4. And this right here is proving our answer. So I know you're probably just writing what I'm writing, but try to pay attention to the last one and this one's the difference between them. The difference between them is that this 30 makes a bigger side this time. Okay, this 30 makes a bigger side this time. Last time it made 2.5, so it was smaller than the 3. Okay, all right, so then when I do this, solve sine of C, which gives me 0.375. So I'm going to do my inverse sine. My reference angle in this one is 22. Okay, in this case, you can see clearly that's an acute angle, so it's only one answer. It's 22. Okay, determine the measure of BAC again. 22 plus 30 is 52, so I want to go 180 minus 52 gives me 128. Angle BAC is 128. Okay, and we have the last case here. Okay. Case 3. So we've done 2, 1. You can understand probably this one's going to be none. So 1 centimeter. The problem with 1 centimeter is there's nowhere that I can do 1 centimeter have it connect. So it's not even going to connect. Okay. So but we'll still plug it in and you'll see why. So we'll say sine of C is still still over 3. Sine of 30 is over 1. When you do that, you're going to get sine of c is 1.5. 1.5 is too big. If you put in your calculator, if you put sine inverse of 1.5, it'll come out as error. That's no solution. So in this case, the reference angle did not exist. All right, so this little conclusions or conditions that we come up with now, this is kind of like your rules for ambiguous case. Okay, if the reference angle is greater than the given angle, there will be two solutions. So if your reference angle is bigger than the given, you have two possibles. That was our first case. Okay, if the reference angle is less than the given, that was our second case, it's one solution. If your reference angle does not exist, if you can't get one, there's no solutions. Okay, and we just have two examples and we'll be done here. So the case for two solutions can also be determined by looking at the two given sides. So looking at sine C compared to sine B. Okay, that's kind of, and then just, yeah, cross multiplying it. Okay, so this right here is going to kind of help us understand what they're saying. Okay, so we want to figure out if there's exactly one or not exactly one. So exactly 1 or 0 and 2. Okay, so looking at this question here, if I just kind of draw this picture real quick, I have an ABC triangle. They tell me I want to find angle C. Okay, angle B is 56. Little c is 10, B is 12. Okay, so from this information, can you make a conclusion of what's the bigger angle, B or C? Which is bigger? Is B or C bigger? B is bigger, right? Yeah, B is bigger because B makes the bigger side. Makes 12. So that makes 12. This has to be smaller. So by that chart we just did, if your reference angle is smaller than the given, you have one solution. So this is smaller, so that means exactly one solution. Okay, I'll let you digest that for a second while I draw this triangle here. P, Q, R. QPR is 41. RQ is 3. PR is 4.2. Okay, a couple things to notice here. One, this is an SSA relationship, side-side angle. Okay, so is this one, side-side angle. But now this one, 41 makes 3. I'm trying to find PQR. So I'm trying to find this angle here. 41 makes 3, then I know that my Q is bigger than 41. So it could be 0 or 2 solutions. We'd have to figure it out by solving first. It's going to probably be 2 though because it's a connected triangle. 0 is when it doesn't connect, but 0 or 2, their answer they're looking for is not exactly 1. Okay, and then actually doing the work with ambiguous. Okay, so find all possible measures of angle C. It's the last thing today. Okay, in the following triangles. Okay, so I have triangle ABC, A, B, C. Angle A is 50 degrees, A is 7.5, and C is 9.5. Find all possible measures of angle C in the triangles. So we're trying to find angle C. Okay, so first off, we asked ourselves, are we expecting one answer or two answers? Okay, 50 makes 7.5. My given angle makes 9.5. It makes a bigger, it's going to be a bigger angle. So we're expecting two answers. Okay, so now we just do the work to get that. We just do our law of sines. So I'm going to go sine of C, which I don't know, over 9.5 equals sine of 50 over 7.5. Okay, multiply that 9.5 over, that's going to give me sine C is 0.9703. Inverse sine, to get my reference angle is 76. So that's one answer. Okay, we expected 2, so I have to do also 180 minus 76. So your two answers are 104 and 76. It's or, not and. It can be one or the other. Okay, same situation here. They just switched A and C on us. Okay, so C is 7.5, A is 9.5, and 50 degrees. So this time, the given angle makes the bigger side. So we're going to get one solution. Okay, the given angle makes the bigger side, so we're going to get one solution. So now again, just set it up. Sine C over 7.5 equals sine 50 over 9.5 times the 7.5 over. Your sine C will kick out 0.6047. Inverse that. And your reference angle kicks out is 37. So that is your answer. Okay. All right. See here. Before I let you guys